Yes. So first we're going to do sum or difference of cubes. Okay.
I'll bring like a bunch.
A bunch. We'll just put them all around the room.
So that then I can slam different doors.
Yeah. We'll line them up, but like give it space. So we'll just have one, and then we'll have like the next few in line, and then you can slam the door, and that one will fall, and then we'll move the next one over. It'll be perfect.
Use your chairs so you know like which height you need to cut the rest of that.
Yeah. Perfect. All right. The funny thing about the clock is it's got on the back of it. There's like that's the part that's supposed to go over the nail, and I couldn't reach it without getting on a chair, so I just had it like hanging precariously on the top. So it was like partially my fault, but I was like, oh, look at this. We can just hang this up. Yeah. I'm like a little bit scared that pieces of glass are just falling. Yeah, there's pieces of glass all over here. Don't touch this area, okay? Just be careful. Okay, I'll have to clean that. All right, so the formula for sum and difference of cubes, you have two options. We have a cubed plus b cubed. That's sum of cubes. And we have a cubed minus b cubed. That's difference of cubes. And when we factor these, we have a formula that we kind of memorize. So sum of cubes starts off with a plus b. That's the first factor. And then the second factor is a squared minus ab plus b squared. So there's kind of like a nice little pattern to it. Ms. Rice, how do I memorize this? I don't know, make flashcards, make up a song. Okay. A cubed minus b cubed, are you ready? A minus b, okay, I see what you did there. A squared plus ab plus b squared. Okay, so here is how I remember this. This is how I remember it. Cameron, you ready? All right. Same sign. So if it's a minus problem, there's a minus. If it's a plus problem, there's a plus. Same sign. Opposite sign. So negative sign, positive sign, plus sign, minus sign. And then over here, always positive, soap. Soap. So whenever I'm factoring a cube, I just say, soap. And then there I go. There's still some memorizing involved. That's all I got for you. That's how it works. Okay. So when we do problems like this, the instructions are just going to say factor. So here's our first example. 27x to the third minus 1. And the first thing I'm going to do is I'm going to rewrite the problem as something cubed minus something cubed. So I can see that the x is cubed, but the 27 is just written as a 27 instead of written as something cubed. So 27 is 3 cubed. So this is 3x cubed minus 1 cubed, because 1 cubed is 1. Isn't that fun? In fact, let's make a list of our perfect cubes. We have 1 cubed is 1, 2 cubed is 8, it's not locked. 3 cubed is, maybe it was locked, 27. 4 cubed is 64. 5 cubed 6 cubed, 2,
Wait, isn't 218?
16. You're close. 7 cubed, 3, 43. Okay. That's about as high as these problems will probably go. I mean, they could go higher, I guess, but these are like the numbers you're going to look for. So just like when you're doing perfect squares and you look for numbers like 25 and 64 and 121 and 36 and stuff like that, when you're looking at sum or difference of cubes, these are the numbers that are going to give you the clue that that's the type of factoring you're doing. Okay, so this is kind of like our A is 3x and our B is 1. Does that make sense? Okay, so it's a minus problem. We're going to remember SOAP. So we're going to start off with same sign. The first one, same sign, the second one. So first term, same sign, second term. So 3x minus 1. Then we have the first term multiplied by itself. 9x squared, so 3x times 3x is 9x squared. Then we have the opposite sign, plus. Then we have the two terms multiplied together, but we're ignoring the negative. We're just saying these two things multiplied, so 3x times 1 is 3x. Then we have always positive, and then we have this multiplied by itself, 1. Now this part right here, if you guys can see, that's a quadratic. The 9 is not a GCF. That would make it a slide divide or a box problem. This last part is almost always not factorable. Very rarely can it be factored. Very rarely. Like if you were like, Ms. Rice, come up with an example where it could be factored, I'd be like, I don't know, give me a few hours. Like literally, that's how long it would take me to find a problem that's factorable. Okay? So for the most part, I wouldn't even worry about it.
What's your answer?
That's your answer.
Oh.
Yep.
You show us how to do this.
No. All right, here's the next one. 125 plus 343 m cubed. So our first step is to write it as perfect cubes. Right idea. So this is 5 cubed. This is 7m cubed. Okay. So it's kind of like our A is 5 and our B is 7m. Yeah, I wouldn't rewrite it. That messes with me too much because it could be the negatives in the middle and you could have to switch the signs and I just don't even mess with it. Yeah. Technically you could, but I'm like, why? Okay. So we start off with this term, same sign, this term. So what do we write first? 5 plus 7m. Okay. Then we do this one times itself, 25. Opposite sign, minus. The 2 multiplied together, 35m. Always positive. This one multiplied by itself. So if you notice, I don't really use the formula. Did you guys notice that? I kind of think about it as just like going in order. I do this one, same sign, this one. That's my first parenthesis. This one times itself, opposite sign, the 2 multiplied by each other, always positive, that one times itself. So it's like you're kind of going through it a couple times. That's how I remember it. If you don't remember it that way, that's fine. You can write down the a and the b every time and just walk yourself through the formula. Does that make sense? Okay. How are you feeling about sum or difference of cubes? Reasonable? Okay. All right, the next one is factor by grouping. And factor by grouping is just like really, really fancy GCF problems. That's like literally all it is. Oh, that's a 3. All right, example 3. 7p cubed minus 4p squared minus 56p plus 32. Yes, you can recognize a factor by grouping because there's typically 4 terms. Or at least like the straightforward problems, there's 4 terms. The ones that we do in Math 3 will have 4 terms.
So if you do swing, do you do swing?
No, swing is when you're multiplying things back out, not when you're factoring. Okay, so we're going to divide it in half. If you notice, it was kind of like in decreasing order. You can see the exponents go down, right? Exponent of 3 to exponent of 1 technically, and then no exponent because no variable. So we're going to take a GCF out of the first term. What's the GCF? P squared. And after you take the GCF out, what's left over? Okay. Then we're going to take a GCF out of the second 2 terms, 8. And what we're going to do, since the leading term of these 2 is negative, we're going to take a negative out with it. So I'm going to say that negative 8 is my GCF. And if I have a negative 56, p divided by a negative 8, what do I get? Positive 7p. And 32 divided by negative 8, negative 4. Okay, what do you notice? The parentheses are the same. Okay, so bear with me. I'm going to say this is the first term, and this is the second term. We got a lot going on, but I'm going to say this is one term, and this is the other. What's the GCF between the 2 terms? The parentheses. See how the parentheses are the same? Okay, so we did GCF, GCF. Now we're going to do a GCF again. I'm going to say what's common between these 2 is the 7p minus 4. I'm going to take it out and move it to the front. And then I'm going to write my leftovers. And my leftovers are p squared and minus 8. That almost looks like difference of squares, but what's wrong with it? Yeah, 8 is not a perfect square, so we're done. Because it wasn't like multiplied. Squared is repeated multiplication. This wasn't repeated multiplication because that's not a times sign right there. So I took it out because I was like, if this is the first term and that's the second term, that's a GCF. It's the same, right? Okay. All right. I'm going to show you guys an example of a grouping problem that is very similar to what the calculus kids would see. Are you ready? Okay. I'm not ready. Okay, let's go. All right. X squared times x plus 1. Yeah, you got to do it. You can tell me to do it. Plus 5x times x plus 1 minus 6 times x plus 1. Yeah. Oh, yeah, because the glare. Sorry, I know anything that doesn't really matter.
Well, I can't see.
Actually, I honestly don't know what it is.
Perfect.
Better? Nothing shattered. Oh, that's not correct. Okay. All right, did you guys write this problem down? Can anyone tell what the first GCF is? X plus 1. So it's kind of like we've got, this is like the first term, this is like the second term, this is like the third term. And we've got an x plus 1, x plus 1, x plus 1. Okay, so we have a GCF of x plus 1. Yeah, and then what's left over? X squared plus 5x minus 6. And you can factor that. Okay, so two numbers that multiply to negative 6, but add to positive 5. You're very close. You're very close, though. Because that would add to a negative 5, and it would multiply to a positive 6. But those are the ones that, like, a lot of times people get those confused because the 1 and 6 go to 5 and the 2 and 3 go to 5, depending on all the signs. So that messes with people up. Okay, one last example of grouping. Probably not as often. I might throw them in here and there, but the calculus kids, they just like forget. They're not, that was a nice one, but it'll start throwing things in like that and they won't even see it. Yeah. Which is why I was like, maybe I'll start throwing them in earlier. So you kind of can start recognizing them. Okay, so we've got 4 terms. That's a classic grouping problem. Split it in half. What's the GCF between the first 2 terms? Definitely an x squared and a 6. GCF of 6. So 6x squared. 5x minus 7. Okay. Ooh, look at this. They're very close. You have to take out a negative 1. So just like we said before, if the leading term is negative, we're going to take out a negative with it. Here, there was not really a GCF, so it'd be like, oh, the GCF is 1. You're never going to have a GCF of 0. You're going to have a GCF of 1. If there's nothing in common, it's a GCF of 1. So I'm taking out a negative 1 because I want to get rid of that negative. I want the signs to be opposite. And now I've got, here's my first term, here's my second term. Yeah, take our GCF out. So our GCF is 5x minus 7. And 6x squared minus 1 are the leftovers. This looks almost like a difference of squares problem, is it? No, because 6 is not a perfect square. 1 is, but 6 is not. Okay. So we're done. Okay. How are your brains? Brains are okay? Yes. Yes.